Okay, so we're trying to solve this equation. So your question looks like this. And if you've been asked to solve it, then you're trying to find x in this type of scenario. And in order to solve it, you can graph both of these functions separately, the left-hand side and the right-hand side, and where they intersect. Those are the solutions to your problem. So it's like a giant simultaneous equation problem, but you're just finding the values of x. So we type in the equations, which I'll do now. So I've typed in my first function and pressing enter, and it's a nice cubic function. I'm now going to type in the second function, which is on the right-hand side of the equation. Okay, so I've typed in the second function, and we are looking at where they intersect. So the first function is a cubic. You can see it's got a maximum and a minimum at the bottom, whereas the red one is a quadratic, and it just has a minimum. So first of all, we're just going to look at those intersection points. So I'll do this a bit more laboriously. So we know we go to Analyze Graph, we go to Intersection, and a little bit easier on my laptop than it is on the screen. So go either side, and then you get your intercept point. Remember, we're just looking at x, so it's 0 minus 0.964. So that's what you would write down as your first solution. So let's do that. So x equals minus 0.964. Note how I don't put in coordinates. I'm just solving to find x. If they're asking for coordinates, they will tell you with this type of question. If you're just solving, you're finding x. Right, let's go back and find the other one. So I am going to grab that solution. Thanks, Halkan, for the tutorial on that. Right, and let's find another one. So going to Analyze Graph again, going to find an intersection, going to go to the left-hand side of the second point, to the right-hand side. Now I should be able to grab it. I'm going to move my solution over here. Remember, it's just the x value, so 0.483. Now, Joseph asked an interesting question regarding significant figures. Now, in your exam, it should be only 3 significant figures. So it should be fine, 0.483. But I know one of the questions in your homework asks for more than that, which is a bit frustrating. But it should be 3 significant figures in your exam. Right, we got one more to go then. So let's go Menu, Analyze Graph, Intersection, go to the left-hand side, go to the right-hand side, and let's grab it again. So it's 2.15. So x equals 2.15. So those are our 3 solutions. Now, as we know, we can do it another way. So I'm going to try and go through it. I think this is it's a dangerous way, and you can easily make mistakes more easily, as indeed I did in the class. So what you can do is you can make your whole equation equal to 0. I think I'm just going to do it in a different color. So your starting equation was this. This is the equation they asked you to solve. So I'm going to make it equal to each other as it was in the beginning of the question. And then what you're doing is you're making it equal to 0. So you're moving everything over to the left-hand side or the right-hand side. So if I'm going to move everything over to the left-hand side, in this case, I am subtracting all of this. And Joseph was quite right to point that out in the lesson, because I missed out those brackets there, which are absolutely crucial. So you're subtracting all of that. So all of the right-hand side now you can see is in brackets. And then you're collecting like terms. So I've got Let's do red first. So I've only got, the only x cubes I've got are 2x cubes. So I'm not minusing any others, so I don't need to worry about that. I'm then looking at my x squareds. So it's minus 3x squared minus another 3x squared. So that is 3 1/3 x squared minus 3 1/3 x squared. Remember, you've got your calculators in this type of question, so you can use them. So if I change that to an improper fraction, which in order to type it in on my graph I may need to do, it is minus 10 over 3x squared. So that's just minus 3 minus another third. And then you're looking at your x's. So minus 2x. Now this is look at the minus, it's minus plus x. So you're actually minusing it. So it's minus 2x minus another x. This minus here is a bit like you're timesing everything on the inside of the brackets by minus 1. It has the same effect. So that means minus 1 times plus x be minus x. So I've got minus 2x minus another x. So I actually have minus 3x. And then last bit, I've got my minus 2, but I mustn't forget it's being times by the minus 1 here. So minus 1 times minus 2 is actually plus 2. And that is equal to 0. So this way of doing it, you're more prone, I think, to make careless mistakes. But it is an option. Right, so now I'm typing in this new graph, so I'm going to get rid of all my old ones. We're typing this in, and we're going to find the zeros. Okay, so I've now typed in that second curve. So now this time, instead of trying to find the intercept points, we've only got one curve. Our solutions we found by where this new graph intercepts the x-axis. In order to find the x-intercepts, then you need to go into Analyze Graph and 0. This is where y equals 0. And that is the same as the x-axis. You can see there, it's already identifying the zeros. I'm just going to do 1. So minus 0.964, just the same as before, and we would get the same solutions that we had before. So you can see the first one matches up, and the others would also be the same. So you have two options there. You can plot both the graphs, the one on the left-hand side of your equation, the one on the right-hand side of the equation. You find the intercepts or the intersection points, or you can make your equation equal to 0 by moving one side of the equation to the other side and then finding the zeros, which are the x-intercepts. And they will both give you the correct answer. Right, what you are looking at today are questions like this. So it's a delightful one, this is. During a locust plague, the area of land eaten is given by that equation, where n is the number of weeks after the initial observation. So find the size of the area initially eaten. So the size of the area initially eaten, that is going to be when n, which is the number of weeks after the initial observation, is going to be n equals 0. So you've got to get used to things like that. So the initial one was right at the start. So that would be when n equals 0. So right at the start, there's no weeks after the initial observations. Right at the start, so n would equal 0. So I've gone back into calculator now. So if n equals 0, let's just go back to the initial question. So if n is equal to 0, and I'm trying to find the area here, then I'm just doing 8,000 times 2 to the power of 0, because 0.5 times 0 is 0. So the equation I'm looking at, or the question I'm looking at is this. So that would be 8,000, which we should know, because 2 to the power of 0 is 1, so you're just doing 8,000 times 1. So first part of the question there, easy peasy lemon squeezy, it would be 8,000. So A is 8,000. Let's look at B then. Find the size of the area eaten after 1 week and then 4 weeks. So we're changing the value of n now. So n is equal to 1 for part I. So again, I just type in same old, go back to my calculator. So I'm doing 8,000 times 2 to the power of, this will be 0.5, which is 11313.7. So 11313.7, 11313.7. So just double check. N was 1, so we did 8,000 times 2 to the power of 0.5 times 1. Now we're going to do after 4 weeks. So n is now going to be 4. So 0.5 times 4, just for the power here, so half of 4, in other words, that would be 2. So we're going to type in 8,000 times 2 to the power of 2. Which is 32,000. So let's write that answer down. Right, now we're actually going to graph it. So graph A against N. So we are going to use our more traditional notation. So I'm going to change it to Y equals 8,000 times 2 to the power of 0.5x. So we're going to graph. Our function is going to be 8,000 times 2 to the power of 0.5x. Now, what we'll find when we graph this is our scale is completely wrong. So if I press enter here, nothing happens. So we can't see it. So it's our scale. So we need to think carefully about our scale here. And there are some clues. So remember, this A is basically our value for Y. And look how massive it is. So when effectively x is 0, y is 8,000. So y is massive. That's why it's not showing up on our graph. And here it's 11,300. Here it's 32,000. So even though the values of x are quite small, we've typed in 0, 1, 4. So, but look at how big the values of y are. So we need to go into our window and we need to change it so it's an appropriate sort of scale. So x wasn't too bad. Let's start maybe on 0, perhaps end on, I don't know, 10 for now at least. We can change it later. And fine, we can put 0 in for y, but remember how far it went up. And it's going to, sort of grow and grow and grow and grow. So I'm going to put in, might sound crazy, but I'm going to put in 80,000. See how much of this we can cover. Right, and now we can see this shows our graph a lot more accurate. Well, we can see our graph. So be careful. Don't be shocked if some of these graphs don't show up. You've got to think really carefully with the numbers you're dealing with. And think really carefully about the scale. So we've done that. We've graphed A against N. So you would probably be expected to sketch that. But I'm not going to do it on here because it's going to look hideous. But you can just look at your graph and sketch from there. Right, how long would it take for the area eaten to reach 50,000 hectares? So what we could do, I will do a very crude sketch, just so we can see what we're doing. So our graph looks a little like that, or this. And what you could do is draw the line y equals 50,000 on your graph, and then see where they intercept. So where your graph meets y equals 50,000, you would then be able to see the corresponding x value of your intercept. So let's do that. So we're going to type in y equals 50,000, and we'll see where those lines intercept. So just put in 50,000. There we go. And again, we know about this. So we're going to go to Analyze Graph. Intersection. You go one side of the intercept point, you go to the other side. So we can see here, let's do a Halcon and take that out. We're only interested in the x value. So what is, if I read down here, what is the value of x? It's 5.29. So that means it would take 5.29 weeks.